This is an explanation for PT79 Game 2. So you have 6 park rangers, J, K, L, M, O, and P, and they're going to be in either area 1, 2, or 3. So the first rule, Mendez is assigned to area 3. So M is always going to be in 3. Neither O or P is assigned to 1. So we know O is not going in 1. We know P is not going in 1. We also know M is not going in 1, right? Because M is in 3. So the only options we have for the first column are J, K, and L. So J, K, or L will be in 1. Next rule, L is assigned to the same area as K or M, but not both. So either L is going to be with K, or L is with M, but you're not going to have both. So you can't have L, K, M all at the same time. So you can cross that out. Last rule, if O is assigned to area 2, then J is assigned to the same area as K. So if O is in 2, then J and K are together. Otherwise, if O is not in 2, then J and K are in different areas. So they are not together. You can cross that out. We could also write the contrapositives to these, right? Like if J and K are not together, then O is not in 2, right? And if J and K are together, then O is second. So there would actually be 4 conditional statements that we can get out of that rule. It is the equivalent of making both of these biconditionals. Biconditional as well. Okay, so first question. We know that M has to go third, so we can cross out anything that doesn't have M third. So D is gone. Next, we know that J, K, or L is going first, right? It can't be O, P, or M. So we have P in 1 here. We can cross that out. Next, if O is second, so O is second here, here, and here, then we know J and K have to go together. J and K are together. J and K are not together. We can cross that out. J and K are together. And then last rule, we can't have LKM all together. We need LK or LM. LK, LKM, they're all in separate rows here, so that's not our answer. So our answer for number 1 or number 6 would be E. And we can write that combination down. So that would be J, K, L, O, P, M. Next question. If O is the sole ranger assigned to 2. Okay. O is the only person going in 2, then which could be the complete assignment of rangers to area 3. So if O is the only person going in 2, and you can have at least 1 ranger but no more than 3 in each area, then you're going to have 2 people in either 1 or 3, and then 3 people in the other column, right? So one column is going to have 2 people, one column is going to have 3 people. So you don't ever have a situation where only 1 person goes in 3, right? Because if only M is going in 3, then you'd have 4 people have to go in column 1. So what could be the complete assignment of rangers to area 3? L and M. Could you have L and M be the complete area? Let's see. L and M are going together here, right? O is in 2, so J and K have to go together. So we can put J and K together here, right? We know that L has to go with either K or M, right? And L, that rule is fulfilled. We fulfilled this rule. We fulfilled the M rule, right? So can we put P in either 1 or 3? Yeah, 3. So this would be our combination here. LMP. So it doesn't seem like L and M can be the sole people. In area 3, M and P. O is the only person here. Again, J and K would have to go in 1. Could we put L over here now? We could, right? Because we're still fulfilling the K L rule, right? But now M and P are the only ones in 3, and that works for C. Exactly 1 ranger is assigned to area 1, then which one of the following must be true? You have only 1 space for 1, then you're going to have 2 spaces and then 3 spaces in these 2 columns. Which of the following must be true? Okay, so if you have only 1 letter here, it's not going to be O, P, or M, right? It's either going to be J, K, or L. So you could have a situation with J, K, or L. We know if J and K are separate, then O can't be in 2, right? So in both of these situations, O would be here, right? And then if O is in 3, well, we know in all 3 of these situations, M is 3rd, right? And then we also know that L has to go with either K or M. So this situation doesn't even work, right? Because L has to go with either K or M. So here, L can't go with K, so L will go with M, right? And in both of these, we know that J and K must be separate. So because K is here, J is going to have to be here. Because J is here, K is going to have to be either here or there. All right, so we filled out 1, 2, 3, 4. So we have to fill out P still, and then we have to fill out L in this row, right? So P just can't go in 1. In this row, it would go over here. And then when we're considering L for this row, we just need L to go with K or M. So K actually cannot go here. L would have to go here with K, and this arrow would not work out, because if K goes here, then L also has to go here, and L can't go with M and K at the same time. So here are 2 combinations that work. What must be true? J is assigned to area 1. That doesn't have to be true. K is assigned to area 2. That doesn't have to be true. L is assigned to area 3. That doesn't have to be true. O is assigned to area 3. That does have to be true. P is assigned to area 2. It doesn't have to be true. Next, what can't be assigned to area 3? So we know P can be assigned here, O can be assigned to 3, L can be assigned to 3, or no, sorry. Yeah, we have an example with L. We don't have an example with K or J, right? So let's see. If we put M in 3, right, what happens if we put K here? If we put K here, L has to go with either K or M, but it can't go with both. And here, L can't go with K or M without going with both, right? Like it has to go here, but that breaks this rule here. L, K, M can't all go together, but there's no other way to put L with K or M. So this does not work. So K cannot go to area 3. And we can even write that in as a rule since it's a global question. and so it applies always. K can never go third. If K is assigned to area 2, which one of the following must be true? So if we have K being assigned to area 2, let me just erase this really quickly. If K is going to area 2, which one of the following could be true? Could Jefferson be assigned to area 2? So if K is going to 2 and J is going to 2, right, and K and J are together, we know that O has to go in 2. And then if O is going in 2, because M is here, right, we know that L and K or L and M have to go together. There's no more space in column 2, so L can't go with K, L has to go with M, and that means that P has to go in 1. But we know, hey, wait, P can't go in 1, right? So this combination doesn't work. So that means J can't be assigned to area 2. That's not possible. So could J be assigned to area 3? Let's see. If K is in 2, we put J in 3. So we have J and M over here. We know L has to go with either K or M, right? So L has to go in one of these two. L is not going here. We know L is not going here. We know K is not going here because K went here, so J has to go in 1, right? But wait a second. We already put J in 3. This seems to be a contradiction, right? There's nothing left to go in column 1. L couldn't go here. J couldn't go here. K couldn't go here. So this doesn't work. Let me erase this again. Just keep going with the options. K is going to 2. Could L be in 1? If we test out C, L, theoretically, it seems like L could go in 1 as long as it's with M or K, but since M's over here and K's over here, this would never happen, right? L can't go in 1. So that doesn't work. O is assigned to area 2. Well, if K is in 2 and O is in 2, then J has to be in 2, right? And then we end up with a situation again where P will end up in 1, right? Because if K, O, and J are here, M is over here, we know that L has to end up with M, and then P is the only letter left here, right? So for the same reasons as before, that doesn't work. So let's see, P is assigned to area 3. So if K is going to 2, right, can P go to 3? If you have M here, you have P here, right? And then you just need L to go with either K or M. So we can put L here. And then we can put O here. We can put J here. And that works with all of the rules, right? So that one works. So for number 10, E would be our answer. Next question. Let's see. Move down a little bit. If L and O are assigned to the same area, which one of the following could be true? So if L and O are going together, this is an example where L and O are together. What could be true? Could J be third, K be second, L be first, O be second, P be third? Okay, none of these are options that we already have, so we'll have to try something out. L and O are assigned to the same area. Since we have L and O being assigned to 3 here, we could try putting L and O in 2. We know that L and O can't go in 1 together because O can't go in 1 ever. So this is a good one to try out since we already have an example where L and O are going third. So L and O are going second and M is going third. And we know that L has to go with either K or M, right? So L has to go with K here. Does this even work? If O is second, J and K have to be second, right? So this doesn't even work. So O and L must go third if they're going together. Okay. If they're going together, they have to go with M. So we know for sure, for a fact, O, L, M are third. So P going third cannot be true, right? J going third cannot be true. O, L, and M have to go third together. And then we also know that O is not going second, right? We also know that L can't go first because L has to go third. So it could be true that K can go second because that's the only option we have left. Just to follow up on that and see what that full combination would go like. If K goes second here, we know because O is not in second, J and K can't be together, so J has to go first, right? And then P can't even go in first in the first group, so P has to go second. So that would be the full column. There we go, full combination. And it would be B. Last question, if J is assigned to area 2, which one of the following must be true? So again, here is an option where J is assigned to. This combination never worked, so that's our only row that we can look at. Does K have to be first? Maybe. Does L have to be first? No. Does O have to be second? Assigned to area 2? No. Does P have to be assigned to area 2? Maybe. Does P have to be assigned to area 3? No, not based off of this combination. So if J is assigned to area 2, which one of the following must be true? We're stuck with two options here, A and D. So if J is going second, M is going third. In this option, we have O going third. We know that O can't go second here, right? Because again, if O goes second, then J and K have to be together, and then we'll have O, J, and K in the third, and in the second group. And then because of that, we'll have to put L over here with M since the column with J is full. And then we end up with this problem where P goes first, even though P can't go first, right? That combination would happen all over again. So since we can't have that, we know that O is not going second, right? When J is going second, O is not going second. And then so because of that, right, we could try putting O first. J and K have to go in separate places. So we could put K here. And then we could put P here because we're only trying to see which one of these must be true. So let's see if P assigned to 2 is true. If we put P third, then the rule with L over here, L has to go with either K or M. So we could put L here or here. Right, let's try putting it here for the fun of it. Does that work? J, K, L, O can never go in one. So this combination does not work. O must go in third. We know that for sure. Since it can't go in 2, O has to go third. Cool. Okay, so then M is going third. And then we know that J and K have to be separate. We can't have K over here, so K would have to go first, right? Because if K goes here, then there's nowhere to put L because L has to go with either K or M. So K can't go with J because O is in the third group, so K has to go first. So it must be true that K is assigned to area 1.